In this chapter, we will be learning about some mathematical functions and some terms and notations which are commonly used for writing an algorithm. So that's why it is named as preliminaries. So these are the things which before jumping into algorithms or before knowing more about the operations which are possible on the different data structures, we will in this chapter we will learn about the different mathematical functions which are used in the algorithm, different notations and the terms which we are using, and what do we mean by algorithm. We studied already what is an algorithm in the last semester. Again, we will just learn what is an algorithm, what is the complexity of an algorithm. All these are the things which we will be covered in the second chapter. So as I told, in one university question paper, most of the question paper which I have seen is one question will be asked is write about some of the mathematical functions which are used in an algorithm, or write some mathematical functions. So for that you can write any of the four, or depending on the marks you can describe. So I have taken out few easiest mathematical functions. So among those are floor and ceiling, remainder function. Remainder function we have already done for most of the programs in the last semester, which is also known as modular arithmetic. Under modular arithmetic, we will learn about the remainder function. And then integer and absolute value function is very easy. Integer function to find the integer part. Absolute value in order to find the absolute value means what's the difference between an integer. Integer can have positive and negative number, but in absolute value we will consider only the value part, that is we will ignore the sign. And real numbers will be having the fractional part, right? Integer will be having only the integer part, while the fractional part will be considered in real numbers. And then summation function, we will see the notation which is used to define the sum of a set of numbers or a series. And then permutation, and we'll see the exponents and logarithm. All these are the functions. So first, we'll see what is this remainder function. We know that when you try to find, we have studied in the last semester also, what is 27 mod 7. What do we do in order to find the mode with a particular number? We have to divide and get the remainder, right? So how to find the remainder? You have to write it as 27 and then divided by 7. It's not like 7 inside and 27 outside. First number which is indicated, you have to write it inside. Okay, 27 divided by 7. How many times it will go? 7 3s are 21. So what is the remainder? Remainder is 6. So when you find mode, last semester I showed you what is the mode symbol, that percentage symbol, right? So if you find mode with mode of a number, you will be getting the remainder. But if you divide, you will be getting the quotient. So depending upon that symbol which we have used. So if you are using mode operator, you will be writing the remainder part. If you are using the division operator, you will be writing the result as a quotient part, right? All these are clear, right? You have studied before also. So in a remainder function, what you have to do is first you have to find the remainder. After that, so when you are finding the mode, you will be writing the result as the mode. Now, when in the definition they are telling it as after finding the remainder, the result will be the remainder. After that, again one cross checking is there in order to check whether the remainder is correct. So we are finding the result as 6, that remainder as 6, and then we are confirming it. So when you are writing a definition, you have to show it in both LHS and RHS, right? So in order to show that this is the remainder of 27 when divided by 7, you have to, how you have to show? You have to multiply the modulus number, which is a mode number here. We are finding mode with 7 means the modulus is 7, right? 7 is multiplied with the quotient, which is a quotient here. Quotient is 3. So 7 is multiplied with the quotient, and then if you add with the remainder, you should get back this number. So the number here we are finding mode is mode of the number is 27, right? We are finding mode of 27, so the number we will be getting back. So in the definition we have to write both the part, that is first we will be getting the remainder, and if you are adding the remainder to the product of the mode number with the quotient, then the number is correct or the remainder is correct. So you are I'm just replacing it with the mode number is with the letter M and the quotient with the Q, and then if you add the remainder you should get back the number which is indicated as K. So in the definition you will be writing in arithmetic modulus, if K and M be positive integers, and then if you're finding K mode with mode M, so K mode M denotes the, so when you are finding mode of a number, it denotes the remainder. Then K is divided by M. K mod M denotes the remainder when K is divided by M. So this will be the definition. So in order to check, as I told, you have to check the reverse way in order to confirm that K is remainder. What you have to do, you have to multiply the mode number with the quotient and add the remainder to get back the number K, right? So so K should be equal to M into Q plus R, where Q is the quotient, R is the remainder, while dividing K by M. So this will be the complete definition. So if you can't remember both parts, you can just write if K and M are positive numbers, then K mod M denotes the remainder when K is divided by M. And write in your own words. I'm just giving the same definition which is given in your textbook. Okay. As Sahana had asked me once about the textbook, all the textbook which are mentioned in your reference list, in the syllabus is all, even for the BCA, it is international other textbook. But in those, no, I started with that, but I understood that you cannot follow that much stuff, and that will be little different way. It's not matching with our syllabus. I don't know why they kept that textbook as the reference, but there are certain Indian authors textbook also. But I'll try asking Ramakrishna sir whether we have the soft copy, or can he scan and send me. Otherwise, you can just follow my notes. Now, for preparing for the presentations and all, you can refer the YouTube videos of good colleges like IIT or some other, like people will be giving international YouTube videos you can refer, or some PPTs you can refer and then understand. Okay. If you are ready to give presentations, you can let me know. Otherwise, I'll tell you the date when you have to present. If you are doing it before I'm taking, it will be well and good. You should tell me if you are ready, but I don't want to force anyone. If you are ready, you can let me know. So here, as I told, you can write both the parts, or if you can't remember both the parts, you can write the first line and then indicate K equal to MQ plus R. You know what is that, no? So if you write where M is the mode number, Q is the quotient, and R is the remainder, you will get back the number K. So you can write one example also. 35 mod 6 will give you 5. So how to get back the number in order to check whether the remainder is correct? Mode number will multiplied by 5 plus 5 will be giving you, will get back you the number. So another example, 25 mod 5, you know, remainder will be 0. So how to get the remainder, to check whether the remainder is correct? Again, multiply the quotient with the mode number plus the remainder will give you 25. Now again, one more example. So I gave three types of example. One is which is not completely divisible by 6. So it will be getting a remainder. Second example is completely divisible by 5. 25 is completely divisible by 5. So you will be getting a remainder as 0. In the third example, I gave a number which is lesser than the mode number. So 3 when you divide with 5, how I have shown you also that example, you will be writing as soon as you see 3 and 5, most of you will be writing what? 5 will be written out inside. It's not like that. 3 divided by 5. Always the first number should be written inside. Okay. So 5, 3 is divided by 5. So how many times it will go? You know, it will not go. It is 0 times. So you'll be writing 0. 5 zeros are 0. So you'll be writing 0 and and the remainder will be 3, right? 3 minus 0 will be 3. So what will be the remainder? Remainder will be 0. So if you are not knowing how to write directly, you can divide and see, and then you will be clear, right? The remainder will be 3. Again, how to check whether the remainder 3 is correct? 5 into 0. That means the number for which the modulus number is 5, right? 5 into the quotient is 0 plus the remainder, we should get back the number, plus the remainder should get back the number. So you got the number k after multiplying the mod number with the quotient plus 3, right? Now the next part is arithmetic modulus. So the next topic is arithmetic modulus. Arithmetic modulus. If you are finding for a number m, it refers to the all the arithmetic operation. You can perform any of the arithmetic operation of addition, multiplication, and subtraction. After finding the performing any of these operation, you will be finding the mode with the m. So if I show you one example, you will understand, and then we'll get back to this definition. So for finding the arithmetic modulo of the particular number 5, we should first define a set of values. For arithmetic modulo 5, the set of values will be starting from 0 to 5 minus 1. That means it is the set of, in maths we will be writing the set of numbers in a curly bracket. So in curly bracket you have to first write and keep the set of values 0 to 4. So we are going to perform now arithmetic modulus. Initially we were performing only modulus. Now the next function is to find the arithmetic modulus. First we will do the arithmetic operation and then we will find the modulus with the m. That is the meaning of arithmetic modulus. So here modulus of m means you can find mode with the, any of the numbers. M can be 1, 2, 3, any of the numbers. So we are first going to see one example with arithmetic modulus of 5. For 5, we have to first set the values from ranging from 0 to 4. So if you take a number like 13, you have to define the set of numbers first. So for 13, the set of numbers will be from 0 to 13 minus 1. That means for it will be up to 12. Likewise, for any number which you take, suppose m is any number, the set of values will be from 0 to m minus 1. Understood? M minus 1. So it will be the range from 0 to m minus 1. So if you take 7, what are the set of values? Nidin, can you tell me the set of values for the number 7 if m is 7?
0 to 6.
So this will be the set of values. Now you are going to perform the arithmetic modulus. For that, suppose I did addition. I did just 3 plus 5. Any numbers you can add. I'm just adding 3 plus 5. It is 8. But when you find arithmetic modulus with 5, 8 is not the correct answer. After finding doing the arithmetic operation, you have to find mode with the 5. After finding mode with the 5, so 8 mod 5, what is 8 mod 5? 8 when it is divided by 5, you will be getting the remainder as, you will be getting the remainder, how many times it will go? One time only, right? Remainder will be 3. So 3 is the answer. So when you perform arithmetic operation, 3 plus 5, 3 plus 5 is not 8, 3 plus 5 is 3. Understood? When you perform arithmetic modulo 5, the answer will be 3. If you are finding arithmetic modulo 7, the answer will be different. Understood? You have to find mode with the 7. Here we should find arithmetic mode with the 5. Similarly, you can do one example. Suppose if you are finding mode with the 7, what will be the answer? So here instead of 5, you can write mode 8 mode 7. What is 8 mode 7? If you are finding mode with the 7, you have to just first define the set of values and then you do the arithmetic operation. After that, you find the mode with the 7. It will be going 1 times and the remainder will be what? Remainder will be 1. So for arithmetic modulo 7, 3 plus 5 will be giving you 1. Understood? For modulo 5, you will be getting the value as 3. So similarly, now if you are under arithmetic modulus, if you are performing modulus with the 12, it is also known as clock arithmetic. Understood? Clock arithmetic. So this clock arithmetic is nothing but finding arithmetic modulus with the 12. You know, first we have to find do the arithmetic operation and then find modulus with the 12. So what will be the set of values for 12? It's
0 to
near
11.
0 to 11. So the set of values will be from 0 to 11. And then you perform the arithmetic operation. So you will be first performing 6 plus 9, it will be 15. Then you have to find mode with the 12. So mode with the 12 will be giving you 3. Our intention is to bring the values down to the range. So you know that 15 is greater than 12. So you will be bringing the number in the range from 0 to 11. Understood? So if you want to find, you know that why it is used clock arithmetic, because you know the timing is from earlier, we will be having only up to 12 o'clock, right? So in order to bring the numbers in the range within 12, you will be using the clock arithmetic. So that's why it is named as clock arithmetic. If you want to write it as a point, you can write under arithmetic modulus. So all the numbers will be taken, after finding the mode, you will be able to bring it down within the range from 0 to m minus 1. So in the case of modulus arithmetic, 0 to 11. Again, one more example, 7 5s are 35. After that, you will be finding mode with the 12. You know, 35 mode 12, the remainder will be 11. If you have doubts, you can do it and check. So here, the next example, it is using a negative number. So when you find the mode of a negative number, if you are finding it difficult, you can leave it. I'm just showing one example. In that case, you need to write only the positive examples. Those who can't understand this negative, I'm going to explain that you can just leave it. When you find mode of a negative number, so in this example, you again perform the subtraction. 1 minus 5 will be giving you minus 4. After that, what you will do, you will find mode with the 12. So the answer will be 8. How it is done? So it is not like finding the remainder. It is a little different. So in the case of negative numbers, you know that 1 minus 5 is minus 4. When you find a mode with 12, what exactly you will be doing is like you just draw the number line. You know that minus 4 is coming on the left side of 0. That is minus 4, you know, it is lesser than 0, right? Greater numbers are indicated on the right side, lesser numbers are written on the left side. So you will be, in order to make it in the range of 12, our aim is, why we are finding arithmetic modulus, in order to get a number in the range, range from 0 to 11. Now, if you have a negative number, what you have to do is count 12 from the negative number. So from here, if you count minus 4 to minus 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when you count 12, you will be reaching the number. So that number is given as a modulus value. So this example, if you didn't understand, you can skip. You can write the positive examples. Okay. That's all about the arithmetic modulus. Now the next concept is, or the next function, among this, whichever you find it easier, you can write for the example. Mostly I have seen they are asking only for the 4 mathematical functions. So next mathematical function which I'm going to explain is mathematical congruence. Congruence is a symbol which is having 3 lines. You know, equal to, we will be writing only 2 lines. Instead of that, if you have 3 lines, it is known as a congruent symbol. So there is some difference between congruent symbol and the equal to symbol. So, but there is, we can equate or we can replace a congruent symbol with an equal to symbol if some condition is satisfied. So we'll see what is that. If you are telling A is congruent to B mod M. So how to read this? A is congruent to B mod M. Yes.
Incongruent, that first equal to symbol will be little curve, no ma'am.
No, that is what we will tell.
They taught us in school like that only. Equal to symbol and yeah ma'am, this is.
No, this is different. I'll tell you, this is what approximate.
That is only congruent.
No, for us, no, this congruent symbol and this symbol is different. This what we will tell approximation. No, this one. The congruent symbol is triple equal to. Then I'll tell you what is this one is approximation symbol. I think I'll tell you in the next class. Congruent symbol, if you search in internet, you will get it as 3 lines. Okay, this is approximate, I feel. I'll tell you in the next class. I don't remember now. So this is indicated as, this is read as congruent symbol. This is approximation, I feel. I don't remember. So in congruent symbol, if you write this as, if you want to read this, you will read as A is congruent to B mod M. Now, suppose I want to replace this congruent symbol with an equal to symbol. How we have to write? A mod M. So what we will do is, we will copy this mod M to both sides. That means, if you are finding mod of A with M, it should be equal to mod of B. If you find mod A mod M, it should be equal to B mod M. That's it. So we, what does it implies that congruent symbol? A is congruent to B mod M means A mod M should be equal to B mod M. Understood? If you are able to find a number for which both you will give the same remainder. So if you are able to find two numbers A and B, which will be giving you the same remainder, that means these two numbers are congruent. So I'll show you one example also. And one more thing is implied through this congruent symbol. That means if A is congruent to B mod M, we can write with the congruent symbol if and only if B minus A is completely divisible by M. Sorry. So you are not taking the minus symbol and all. If you just find the difference between A and B, that number should be completely divisible with this number with which you are going to find the mod. Don't get confused with the definitions. I'll show you one simple example. What is the meaning of 25 congruent 7 mod 3? How you can replace this congruent symbol? Can anyone try? So if you are replacing 25 is congruent to 7 mod 3, what you have to write? Nagraju, can you just tell me? Who is not there?
Ma'am, we have to find. Ma'am, we have to find 7 mod 3, ma'am, first.
How to replace this congruent symbol? I told to replace congruent symbol, what you have to do? Copy this mod 3 to both sides. That means you have to find
25 mod 3.
25 mod
25 mod 3 and 7 mod 3.
You have to write first as 25 mod 3 equal to. So we will find whether it is equal. You just copy mod 3 to both sides. 25 mod 3. Then you replace this congruent symbol with an equal to symbol and then 7 mod 3. So what is 25 mod 3? When you find the remainder, 25, when you divide with 3, what will be the answer?
Remainder is 1.
Remainder is 1, right? 8 3 is 24 and the remainder will be 1. Now, if you find 7 mod 3, what will be the answer is? If you find mod with the 3
Quotient is 2, so remainder is 1.
Again, the remainder is 1. So both you got the remainder is 1. You will replace it. You will write 25 mod 3 is 1. And then 7 mod 3 is also equal to 1. Then you can write, or that's why we are equating it as 25 is congruent to 7 mod 3. Now this part we have completed. Now the next part is if and only if you can write or equate A is congruent to B mod M, if and only if B minus A is completely divisible by M. B minus A or A minus B, there no problem. Here we are considering only the
25 minus 7.
25 minus 7 is what?
18.
18.
Divided by 3 is 6.
18 is completely divisible by 3, right? 6 3s are 18. So this part is also clear. So if you are able to find, you will be able to equate A is congruent to B. Here in our example, 25 is congruent to 7 if it satisfies these two conditions. That is, if 25 mod 3 is equal to 7 mod 3 and if B minus A is completely divisible by N. So these are the, I hope it is clear now. If you are able to find these two, then you can write it with an congruent symbol. This is known as mathematical congruence. So this function of congruent symbol, you can explain with this. Any example you can take and then write. Tell me the difference between a real number and an integer number. So real number will be having decimal or the fractional part. So if you are taking 3.6, right? So what are the two nearest integers of 3.6? two nearest integers to which we can round off. You can make the higher part, if you are taking the greatest greater than 3.6, if you are taking, it will be 4, and lesser than 3.6, if you are taking, it will be 2, right? Some of you are answering the chat box. Right. So when you this is a real number, and when we are rounding off, you may round off to a greater number means 4, lesser number means we will be making it as 3, right? So now that is if you are finding all the integers which are greater than 3.6, it will be like 4, 5, 6. Just listen, no? If you understand this, that concept will be clear. We are going to learn about a concept called floor and ceiling. So before that, you just understand real number means 3.6 is a real number because it's having a fraction part. The nearest integers will be the greatest integer will be, or all the greatest numbers, if you are listing, it will be 4, 5, 6, right? But among these 4, 5, 6, the least integer which is not lesser than 3.6, right? So if you are finding, you know that 4 is also greater than 3.6, 5 is also greater, 6 is also greater, but among these, which is the least number? 4 is the least number. So what is the significance of 4? 4 is greater than 3.6, and then among the list of 4, 5, 6, 4 is the least number, or the smallest number. 4 is lesser than 5, 4 is lesser than 6, right? So the least integer which is not lesser than 3.6, but 4 is not lesser than 3.6. You know, there is a difference of 0.4, right? So it is not lesser than 3.6, and it is the least integers among the least, the numbers which are greater than 3.6, it is a least integer. So this is considered as a ceiling. Ceiling is a notation, and it's a mathematical function which will be finding the least integer which is not lesser than 3.6. So I'll show you the notation in the next slide. But now for the understanding, I'm just showing, if you are listing out all the integers which are greater than 3.6, what are the integers which are greater than 3.6? 4, 5, 6. Among these, 4, 5, 6, etc. I have given. Among these, the number which is least number, 4 is the least number, which is not lesser than 3.6, and it is among the numbers, least among the numbers which are greater than 3.6. So this is considered, 4 is considered as a ceiling of 3.6. Now, the next concept, for that you have to understand that you can also round off 3.6 to 3, or we can consider the, if you are considering the integers which are lesser than 3.6, if you are considering the integers which are lesser than 3.6, you may write it as 3, 2, 1, etc., right? But the greatest integer, greatest among these, among 3, 2, and 1, which is the greatest integer? 3, right? Greatest integer that is not greater than 3.6, right? So 3 is not greater than 3.6. So this is considered, among these numbers, 3 is considered as the floor of 3.6. So the mathematical function, not read as floor, I will show you the notation. If you are finding floor of 3.6, the answer will be 3. So the definition I'll show you in the next slide. So the negative numbers, you'll get confused. You just learn only about the positive numbers. So if you consider x as a real number, tell me an example for a real number. Janani?
3.4, ma'am.
3.4. Any number with a decimal part you can consider as a real number. Now, what is floor of 3.4? So for the definition, it denotes the greatest integer that is not greater than 3.4. You have to find all the greatest integers. First, you find all the greatest greater integers than 3.4. You know that 4, 5, 6, all these are the greatest integer greater than 3.4, right? Now, which is not greater than 3.4. So the greatest integer that is not, so not greater means which is lesser than 3.4, right? So you will be finding all the numbers. Suppose in this example, if you're finding 2.6 as a real number. If you find all the greatest integer, you will be listing out which all will be the, one second, greatest integer that is not greater than. Sorry, I was telling about the ceiling only, no? So in this example, in the previous example I have written, so first you have to find all the integers. When you find the, this is a twisted definition, so you'll get confused. Great. First you have to find all the integers which are lesser than 2. That is not greater than x, means you have to list out all the integers which are lesser than 2, which are 2.6, which are the numbers which are lesser than 2.6. It will be 2 and 1. And among this, which is the greatest integer? 2 and 1, which is the greatest integer? 2 will be the greatest integer. So 2 will be the greatest integer that is not greater than x. So you have to first part consider the last part of the definition, which is not greater than x. Then only you have to move on to the first part, that is the greatest integer. So this will be a twisted definition. So first you have to, suppose for our example, just now she told 3.4. So what we have to first consider is the second part of the definition is integer that is not greater than x. So the real number which Janani told is 3.4. So first we have to find the integer that is not greater than 3.4. What are the integers which are not greater than 3.4? So you will be listing it as 3, 2 and 1. Got it? After that, find the greatest among these integers. Which is the greatest among these integers? 3 is the greatest. So what will be the floor of 3.4? Floor of 3.4 will be 3. So
3.
one more example can you give? Somebody?
13.5.
No, 13.5. So when you take 13.5, as I told, you have to first consider the second part of the definition. Find, so 13.5 is a, what type of number it is? It is a real number. You have to find all the integers that is not greater means what? It is lesser, right? So lesser than 13.5. So you'll be writing it as 13, 12, 11, 10 like that, right? So you have listed out all the integers which is not greater than x. So you'll be writing 13, 12 and then 11 like that, etc. So all these are the integers which is not greater than x. Not greater, 13 is not greater than 13.5. 12 is not, you check it after writing, 12 is not greater than 13.5. Now, after this, find the greatest among this. Greatest among 13, 12 and 11 will be 13. Got it? So this will be indicating the floor of a number. And for this, one notation is there, floor of a particular. So you will be finding the floor of a real number. So the notation which is used to find the floor of a number is just like our square bracket, or which is not closed on the top. You know how to write a square bracket, right? So for the floor, you have to indicate, suppose you are finding floor of 3.4, you have to indicate with the symbol this. Got it? So this notation is known as the floor symbol. Okay, is it clear? So if you are getting confused, don't go for this negative example. Write one positive example. Okay. So if, as I told, the only question which I have found in the university question paper is write any 4 mathematical functions. So you can write floor function. If in case, no, like as I told the before examples, no, arithmetic modulus and congruence. I took out the easiest one among those mathematical functions, and later on 2, 3, 4 examples are also, no, functions are also there. Whichever you find easy, you can write. Got it? So this definition is given like that, so I gave like that, but the actual concept which I have given before, if you can understand, you can write it, or you have to write when you are doing executing, you have to find the second part of the definition first, which is not greater than x. Then what is ceiling function? This I had given as a first part in my example, that's why that confusion came. So what is now ceiling function? If x is a real number, which is a real number? Tell me an example. Pradeep, can you tell me an example for the real number? Pradeep, are you there?
Yes, ma'am.
Tell me which is a real number. Another example for real number.
4.5.
4.5. So now, what is now ceiling of a number? It denotes the least integer that is not less than x. So you have to again take the second part of the definition first. You have to find the integers that is not lesser than x. Not less means what? Greater than 4.5. So all those integers which are greater than, they have given like like opposite manner. Not less means greater than, right? Greater than 4.5. What are the integers which are greater than 4.5? You just list all the integers for 5, 6, 7, etc. Among these integer, you can just put etc. You know, all these are 5 is not less than 4.5, 6 is not less than. So all these are the integers which are not less than 4.5. Now what you have to find? Least integer among these. Which is the least integer? 5 is the least integer. 5 is lesser than 6, 5 is lesser than 7. So when you find the ceiling of 4.5, the answer will be 5. So likewise, I have given one more example for 2.6. So you need not write this example if you find it difficult. I have the slide, but I am not going to tell that because you will find it difficult. If there is offline class, I'll explain it. Okay, then the notation for, so I have given both the notation. Here for the ceiling, it is as again the square bracket symbol, but with the with that lower part removed. So for ceiling, you have to put the notation in the opposite manner. For the floor, we have put like this. Floor means, you know, our flooring, like that you have to remember the square bracket with the lower part, that is for floor. And for ceiling, it is that square bracket with the upper part. For floor and ceiling, in our room we have floor and ceiling. No? So ceiling will be having upper part. For floor we have the lower part. Okay. Now, one more thing you have to, you can just write one more point. That is, if x itself is an integer, we are finding the floor and ceiling for the real numbers, right? So if you are considering the floor of an integer itself, tell me an example for an integer. Tell me an example for integer. Manigandan. Manigandan. Tell me an example for an integer number.
5, ma'am.
5. You are just taking 5. Now, if you find the ceiling of 5, if you find the ceiling of 5, it will be the same as the floor of 5. You know that it is an integer, so you will not find an integer which is not greater than 5. 5.0, it is same as 5, right? So for both the floor and ceiling, if you find with the definition, you will be getting the same number, that is 5. Got it? So this is if you're finding the floor and ceiling of an integer. Got it? If you're finding the floor and ceiling of an integer, that will be the same as that integer. Floor of the 5 will be equal to the ceiling of 5, that is equal to 5. Now, suppose if you're finding the floor of a real number, so it is for that examples, whatever we have done, also you can just try out. Floor of a number. So ceiling of a number, here I have given the notation for ceiling, right? So ceiling of a number, suppose we are finding the, here the example we have given as 2.6, right? If you are finding the ceiling of 2.6, ceiling of 2.6, we got it as 3, right? Ceiling of the number plus 1 will be giving you the floor of the number. Suppose we find the ceiling, the floor of 2.6. I have given in the previous example, I think. It will be, the floor of the number is 2, means the ceiling of the number will be 1 greater than that. So that is what I have given over here. If you find that these two are related like that, floor of a number plus 1 will be giving you the ceiling of that number. Floor of the 2.6 is 2, while ceiling of 2.6 is 3. So it is like a ceiling of the number I have given wrong notation. Floor of the number plus 1 will be giving you the ceiling of the number. Understood? Floor of 2.6 plus 1 will be giving you the ceiling of that number. Suppose we are finding the like as I have given in this example, if you find the floor of 2.6, it will be 2, right? So if I write 2 plus 1, what is ceiling of 2.6? Ceiling of 2.6 is 3. So that will give you 3. Got it? So floor and ceiling is related like this. This is for the real number. If you're finding the floor and ceiling of an integer, both will be equal. So floor of a number will be, an integer number will be equal to its ceiling, ceiling of that same number. Now, after this, we have some easier concept also, but depending upon the mark, if it is very less mark, you can write functions like integer function and absolute value. So you know what is an integer function. If you find the, suppose we have x as a real number. Now you know what is a real number, right? 3.4. So if you find the integer value of 3.4, so we will just delete the fractional part of that number. We are not seeing the floor and ceiling. We are just removing. So this, if you find the integer part, you will be just giving it as 3. We are not seeing whether it is greater than that fraction part is greater than 5. We are not rounding off and all. We are just removing the fractional part. So what is integer part of 3? We are just cancelling the fractional part and writing it as 3. What is the integer part of minus 8.5? We are just cancelling the fractional part and writing it as minus 8. Got it? This is integer function and we are denoting it as int. So in algorithm also, if you are just using the notation of int and in bracket, if you are denoting any of these real numbers, it indicates that we are taking only the integer part and we are just cancelling the fractional part. Okay. Now, what is the next function? I might have kept in 2 different slides. This is another function called the absolute value. You might have studied in the schools also. Absolute value describes with the definition. If you go, it is just like describes the distance of a number on the number line. You know a number line, right? From a number line from 0 without considering the direction. So if you are just telling an example, it is nothing but absolute value of number removes the negative or the sign of that number. If you just take the absolute value of minus 6, absolute value will be 6. Ignore the sign, that's all. For positive numbers, we will not consider because we will not write sign. And for the negative numbers, we will find the absolute value means it will be giving you the positive number. That's it. So we are just ignoring the sign of that number, negative sign of the number, and taking only that absolute value of the number is indicated by the notation either ABS or by 2 lines which is drawn on either sides of that negative number. So with the definition, if you go, it is describing the distance of a number on the number line from 0 without considering the direction from 0. So you know that from 0 you can either go for the positive side of positive 6 or to the negative side, right, minus 6. If you are just ignoring the direction from 0. So if you are just ignoring the direction, if you are taking only both sides, if you are considering it as positive, so it will be the distance from 0. So this will be taken as a absolute value. You can either indicate with the ABS or with a double line on either sides of the negative number. So this example also you can write. So this part you have to understand the difference between integer function and absolute function. In absolute function, we are removing only the sign, while in integer function, we will remove only the fractional part. Here in this example, minus sign will remain. Understood? Here in this example, the fractional part will remain. That's why I gave 2 examples. Absolute value will remove only the sign, negative sign, while the integer function will remove only the fractional part. So these 2 examples also you can write if it is for very small marks. Okay. Then summation symbol. Summation symbol is indicated with the symbol called sigma. Sigma. So this symbol is read as sigma. And if you want to find the sum of all the values, in a particular algorithm. If you want to find the sum of a range of numbers, you will be using the notation called sigma. So here in this example, if a1, a2, a3, you can write it, you can replace this a1, a2, a3 with the numbers like 1, 2, 3. I'm just indicating the sequence with a variable a1, a2, a3. Then their sum. What is the sum of these numbers a1, a2, a3? a1 plus a2 plus a3. What is the sum of numbers like 1, 2, 3, etc.? It is 1 plus 2 plus 3, right? Plus etc. We will write. So if you are finding the sum of a sequence of numbers like a1, a2, a3, we will write it as a1 plus a2 plus etc. And you know the last number. Suppose I have given the last number as an. So to find, to denote in algorithm, we cannot write a1 plus a2 etc. and all. So we will be using the symbol called sigma and indicate that integer with a common variable called aj. Got it? Every number is having a, right? So we'll be writing a variable called a and then with a subscript called j, where j value will be ranging from 1 to n. Instead of writing 1, 2, 3, we are just indicating it as j, and down we will indicate that j value will be ranging from 1 to, I didn't write n, 1 to n. Got it? So this way you can write in an algorithm. All these symbols we are studying only to rewrite or to write an algorithm in a crisp manner, right? We cannot elaborate and write the steps in an algorithm. So we'll be using such notations, replacing this summation. We will be using only variables in an algorithm and in a program. We will not write 1 plus 2 plus 3 and all. So we will be using some variables in order to show the sum of the numbers. We will be indicating it as we will be using the notation for sum, that is sigma, and followed by the variable which we have used. You can use any of those variables. Like how we declare a variable in a program. You can use any of the variable name, and then here I have used a variable called a with a subscript j, where j value will be ranging, right? So here if I'm ranging it as 1 to n, you can write it as j value will be ranging from 1 to n. So this letter j which I am using, if this along with the sigma notation variable, it is known as a dummy index or the dummy variable. So suppose I have another series called, so here in this example, I was finding the sum like 1 plus 2 plus 3 plus etc. up to like, if I want to find the sum of the numbers up to 100, I'll be writing like that, right? So if I want to find the sum of the square of the number in one algorithm, I want to find sum of the square of the algorithm. So I cannot write it as 2 square plus 3 square. I need from 2 and I should be up to 5. So how to rewrite that in an algorithm using a summation symbol called sigma, where j is that dummy variable or the dummy index. So how to write it? So again, you have to rewrite this 2, 3, 4 with a variable. You can use it as a. Oh, it is going up. That was the previous one. Animation is wrong. Okay, so here you can use, here you are finding the, you are using the variable called, why I use the same variable? The variable okay. Here I am using the variable called j. Listen here, this summation is different from this summation. Here I am going to find the sum of the square of the number. So here j value will be ranging from, first we are giving a summation notation as sigma. Here the variable which I am going to use is j. So here in this example I was just using a j, right? Where j is a subscript. It is not shown.